And it should be the same.
And when they're using it as an,
Bit of it off the internet and I put it in on like on the master set. I think it's right though.
Man, I was like so lost.
It's blanket, all right. So first off, before we do the quiz, are there any questions on the chapter 14 homework?
Yes, whenever it says displacement, is that the same as the amplitude? Like if it doesn't mention the amplitude and it just says displacement?
If it's the initial displacement, then yes, well, yes.
Right, if it's the initial displacement, it's the amplitude.
If it talks about that, it's displaced from its equilibrium position, and then let go, that would be displacement.
Okay, so.
That would be the displacement, that would be the amplitude.
So an example would be on number 4, and it says it's displaced downward 0.85 meters and released, that's the amplitude?
Yes.
Okay. Cause I was so lost on that. I was like, there's no amplitude here, so I don't know what to put on in the equation, so.
Yeah, my hesitation is, there are certain standards that a lot of textbooks use, but not every textbook. And so I could give similar information and obscure what the displacement or what the amplitude actually is.
Mm-hmm.
So, yeah, when you're displacing something, the question generally is relative to what?
Right.
And so within that context, yeah, that's the amplitude.
Okay.
All right, any other questions right now? All right, then I'm gonna pause this, pick up the stuff on the printer, right next door, and we will have this fun activity. All right, rolling again. All right, so Nick, you wanted to look at small angle approximation, at least the question around the percent difference?
Yes.
All right. So the essence of it, again, and this should not be a shocking thing, but the small angle approximation is generally written as the angle is much less than 1. And again, there's no units here, so it's implied radians. Then theta is roughly equal to the sine of theta, which is roughly equal to the tangent of theta. And so we exploit this in our simple pendulum with the sine of theta. And so part of that question is around at what point does it really seem extreme of we really should not be using small angle approximation at all. And well, it depends on what you're doing. If you're building something where being off by 10% is a life or death thing, then yeah, you probably should not use small angle approximation. If you're building a building where there's so many factors of safety built into it, then yeah, small angle approximation, I'm not quite sure where you'd use it in that case, but small angle approximation, you probably can get away with a couple of places. So, to start out with your calculator, make sure it's in radians. What's the sine of 0.01?
.009.
Give me 2 more decimal places.
999.
I assume the next number is not 9.
Yeah, it's 9.
It's, how many 9s do we have?
4. 4, and then there's an 8.
Is it, if we rounded off at that point, would it round off at 8 or?
No, it rounds off, yeah, it would round.
It round to 8, okay.
Yep.
We'll go with that. So the percent, in the question I asked you, I said, when is it 10% off? And I kept it vague, because there are several ways you can actually look at it. So for example, percent difference is, I'm really comparing them to each other, or not, I'm not comparing sine to this, and I'm not comparing that to this, I'm just comparing them to each other. And so my percent difference would be the difference between 0.01 minus 0.00999998 divided by the average of the two. And what would that get you?
Something's pretty small.
That times 100%.
It's 2.00002 times 10 to the negative 5. Oh, wait, no, it's not times 10 to the negative 5. It's 0.020002%. Yeah.
So 0.02,
0.2.
another zero in there? 0.002.
0.0002.
All right,
Yeah.
tiny. Let's just go through the process for at least the next three. Why don't we split it up? So I guess Adam take 0.1, Nick 0.2, John 0.3. You can either wait till you have it all, or you can just sort of tell me as you get it.
The 0.3 is 1.50.
Oh, you're doing the percent?
Yeah, 1.504. I'm rounding off up to 5.
Is it 4 or 5%?
Yep. Yep.
What was the sign value?
The sign was 0.2955.
Adam, you got your 0.1?
Yeah, the sign of 0.1 is 0.0998. The difference is 0.1 minus 0.0998. Percent difference, right?
Percent difference, all right, so 0.1 minus 0.0998
Yeah.
divided by the average of those two.
Oh, hold on, let me. Oh, yeah. The percent difference is 0.0999.
Percent?
Yes, sir.
I get 2. Or the sign is 0.198669338.
All right, and the percent difference?
I think 2. I keep getting 2 out of my calculator, like 2%.
Well, that's 2%, but this can't be 1.5%.
I keep plugging that, I keep plug it in and it gives
Is
me.
it in radians?
Well, the fact that you got sine of theta, really close to
Yeah.
0.2. So the percent difference would be 0.2 minus 0.198669338 divided by the average of those two numbers, 0.2 plus 0.19.
No, I got something different. I got 0.66755%.
Oh, okay. 0.66,
Five, or seven, sorry.
0.667?
Yeah, 555%.
I put something in the calculator wrong.
All right, are you getting this now, or?
Yeah, I got it now.
Okay. All right, so at some point, the 10% rule shows up a lot when you're doing approximations, that if, typically in physics, you allow the small angle approximation if theta's less than 0.1. That's generally 10% of the value you're comparing it to. Is the rule of thumb for the rule of thumb. Because we say if theta is much less than 1, and so this means roughly, in physics circles at least, if theta is less than 0.1. So at that point, you're still, you're off by 1 in 1,000 there. Now we're still under 1% at this point, it's only 1.5% at this point. At some point, we're gonna hit 10%. And so that question is, at what point do we actually hit 10%? So one approach is to, just sort of leapfrog and then start narrowing down from there if you're doing it by hand on the calculator. So it seems like it's somewhere around 0.7, but I'm going off memory off several different things running through my head right now.
When I did it, or, did it on lab, I got something like 24.62 degrees. So
Okay.
I could just make that into radians. See if that.
So that would be somewhere around here.
Yeah, something like that, yeah.
I got like 45 degrees, but I don't know if that's.
Well, so 25 degrees. So I think you're roughly in the same ballpark, right? You said 24.
24.62, yeah.
So,
And I rough 57, or 24.62 divided by 57.3, and I'm just gonna do that.
okay.
So, it's 4.2, it's 0.429668
Radians.
radians, yeah.
All right, and the sign of that?
I will, it's a 0.41656.
And so the difference would be 0.01310 divided by the average of those, of this and 0.4, would be 0.414834.
Let me see.
This is just comparing the angle to the sine of the angle. There was another question where you're asking to compare periods. Because this is what, about 2.5%?
No, it's 3%,
3%?
3.959.
Alright, so, I did say 10%, right?
Yeah,
Okay.
so it should be 10.
Yeah, at the point where you get to 10%, so it is a larger value than that.
Okay.
You know my phone, you got mine.
What was the master set, right, that question?
No, that was on the lab.
The harmonic motion lab?
Yes.
Simple pendulum lab.
Oh, yeah,
Pendulum
simple.
lab.
Sorry. Alright, obviously, Nick, we didn't give you the answer, but is it clear what you're trying to do on that question?
Yeah,
No, I'm still, so I'm just gonna be like working down this list.
No, you're working on
You
the
did.
angles here, the angles that we have on the graph, that's what you're working down on.
you could theoretically just put in 10% and then find theta, sine of theta.
That's a little bit more difficult here. Because I got two moving targets.
But you don't know, like it could be 0.86 and you'd never know. Like you would never get like exactly 10%.
No,
Unless you were to do that.
Now, I guess a simpler way, okay. True, but you should be able to narrow it down. All right, so this is too small. Jump to 0.8. Okay, too big. Okay, jump to a smaller number. Say 0.4. Okay, too small. Let's go and just start working your way, narrowing down what it is. It's gonna be a progression. It's not like you're gonna do 0.1%, 2%, 4%, 1%. You know, it's not gonna skip like that.
But what I was having trouble with was, what if it's bigger than 1 radian?
It won't be.
Okay. So it can't be bigger than 1 radian, because then it's defies the small angle approximation.
Wait, then what?
It defies the small angle approximation.
No, that definitely, you would not use it at that point,
Yeah.
but.
And what's the formula for degree, degrees to radians again?
It's a degree is 57, or 1 radian is 57.3 degrees.
It depends on how you wanna do it on your calculator. These two are equal to each other, so the conversion is 360 degrees over 2 pi radians, which is 180 degrees over over pi radians. If you did that division, you would get the number to 4 significant figures that John's talking about. So you said degrees to radians?
Yeah.
Okay, so for degrees to radians, then we would flip it. So 30 degrees is, to get it to radians, is times pi radians over 180 degrees. You want it so that the units that you want to get rid of cancel out, so you have 1 on the top, 1 on the bottom. And so you end up with pi over 6 radians, which is 0.5 something.
Let's do 6.1.
Okay, 0.61,
0.61.
that's what you got, the 10%?
I'll
Or
try it.
you're close there.
I think so, that's pretty close. I'll try it. 0.61. Closer, but no.
Yeah, so I mean, the process you have down, at least. Nick, let's get back to some of the questions that you were asking. Where are you on this?
So, okay, so question 3 has nothing to do with any information that it's just asking what angle is the small angle approximation off by 10%.
Yep,
Okay,
that has nothing to do
Okay.
with that specifically, other than the fact that the simple pendulum has the assumption that small angle approximation is valid.
okay. So it says determine the angle at which period is 10% off of the theoretical value.
Alright, so now we're talking specifically about that. And again, the term 10% off is vague. There are other ways we could have done the percent off other than percent difference, but. So now we have an actual target, we know what the theoretical value is. So let's say that the period was 4.78 seconds. I don't think that was the number that you had, but just pretending. So I'm 10% off of this, which means that I'm either higher or lower. So 10% off of that, well, 10% is 0.478, multiply times 0.1. And so 10% off means that on either side of it, it would be, well, let's do it the old-fashioned way, 4.78 plus 0.478. So 5.26 on one side and 4.78 minus 0.4, I'll just round off 0.48. So as you're working your way down, whenever you hit those targets, one of those targets, or pass it, it depends on as you start working it, is the period steadily getting bigger or steadily getting smaller?
So whatever angle we have here, if it goes above or below those two values.
For the period.
Found it, it's
Yeah.
0.77.
All right.
It's, down to